The next thing I want to take a look at here is our historic weights report. You can see on this SQL server, there's these blue bars across the top. If I click on this other one, you can see that it's not yet configured. What you would do is you would click there and you would use the current instance for monitoring. And what that does, it sets up a SQL agent job and a monitoring database on that server. We're not going to do it on that one right now because I already have it configured over here. And then it tracks information as what's going on over time. Here's a side note that's really interesting as we look at the performance here. On February 3rd and February 4th, I have this is my development desktop, my home office. I have a RAID 10 array that I use for, not for my boot disk, but for my data files and all that. And if you're familiar with RAID 10, it's striped and mirrored. And I had a disk failure in one of the 4 drives in that RAID 10 setup on the 2nd, and I wasn't able to get the replacement disk until the 5th. Between that time frame, I had some pretty degraded service running on that RAID array with one of the disks in a failed mode. Didn't lose any data, but it was just slow running in that degraded mode. So if we look here, we can see over time when we look at these charts of weights, and this is looking at SQL Server weight stats, which if you're not familiar with SQL Server weight stats, every time SQL Server is working to do anything and it's stuck waiting on something, it logs that as a specific weight stat. So for instance, if it's waiting on memory allocation, it logs that. If it's waiting on IO, it logs that. If it's waiting on a write to a log file, it logs that, or parallelism, things like that. What I'm looking at here, though, is we can see on February 3rd and February 4th, there was an unusual spike here, way out of the ordinary. And if we go back 2 weeks or even 1 month, I mean, there's never been a spike of weights on my system like that before, because the databases were running, and these are test databases, of course, so there wasn't any concern over real data, but the test databases were running off of a failed disk that was running much slower than it should have been running. And when we look here, we can double click and see, well, the biggest query that was having issues was a stored procedure called update issues history, and it was having problems with CX packet and CX consumer. Normally, when you see CX packet and CX consumer, you assume, well, if we double click on CX packet here, it'll tell us some things, but you can assume things like MacStop, or if we click here, we can bring up some more help on CX packet that talks about the common things around CX packet are maybe you've got missing indexes, CPU pressure, memory pressure, out of date statistics. I mean, these are all the things you would normally chase to go find out why it has CX packet weights. But one of them that's the abnormal thing that CX packet weights is if your IO is extremely degraded because you're running on a failed array, like I was at that point, it takes a lot longer. So CX packet is saying that a query has gone parallel and it's running on multiple cores, and it takes longer for all that data to come back. So there's a whole lot of time that it's waiting for things to complete before it returns that query. And the waiting is not caused by any of these normal things on this specific environment. It's caused because I had a failed drive that was very degraded at that point. But let's jump back here and put this to 2 weeks, and we'll look at kind of a more realistic environment where we didn't have a failed disk. So here we can look at these different days and see that, let's go a little bit further back here. Okay, so here's a pretty typical week where there was a spike on December 31st, but January 1st and on, everything's kind of a constant pattern there. And usually when I'm looking at the historic weights, when I see a constant pattern or an occasional spike like this, that goes away the next day, that's not out of the ordinary. What I'm looking at is kind of the trend over time. And when you see the trend, there's nothing that ordinary but let's look at what was going on 12/31. Well, on 12/31, somewhere around 3 a.m., there was a lot of weights associated with an SPOA method call. Oops, I clicked the wrong one. And if we double click on that, we can see what the SPOA method is used for in this specific case is it's used to do a web service request. And this specific web service request, the site that it was requesting from was down. So I know that this specific time, that's explainable as to why there was a problem at 3 to 4 a.m. on December 31st, because that specific site it was trying to talk to was down. So that kind of rules that out as something I would chase to improve performance. Then I'd look next at, okay, well, the next one here is DBCC CheckDB. Well, it varies on time depending on load and other things on the SQL server. But what we're seeing here is that CheckDB takes a fair amount of time. And if you're familiar with CheckDB, or if you're not, what it does is it goes out and it scans your entire database. Well, that's something that is usually not a big deal because you've usually got it scheduled at a time that there's not any issues going. I mean, that there's not a lot of load. And an important thing is it does take a lot of waits. Because this is my test environment and I have maintenance jobs and things like that running, I don't have a lot of real queries running. But here we look at something like this query, delete outliers. Well, this is something that we can see over time, January 11th, January 13th, January 19th, that this is something that increased over time. And as we got up to around February 2nd or so, it kept getting slower and slower and slower based off of parallelism. And I think that may have been related to the point in time where my drive was starting to fail on my RAID array. Perhaps my RAID array has thrown off some of the real data here. What I'm normally looking at here, let's just go back. So once it's enabled, we're looking at this. And then if we zoom in on something like one day, here's today, and we can see that today in the 9 a.m. hour, and I'm going to click on 9 a.m., that we had blocking specifically from 9:13 my time up until about 9:20. When you see something like this where it's stacked bars that you continue to grow and grow and grow over time, that usually means that it's the same thing that's stuck and the weights associated with it are just starting to pile up. So in this case, this was our blocking test. We can click on it and see, well, what was it waiting on? Well, it was waiting on a lock in order to be able to do the update. When we ran the performance viewer and we caught the blocking query, that showed us what the culprit was or what the blocker was. This is showing us who the victim is or who is actually waiting on that other query. Using a combination of the historic weights to track over time what's going on at specific times, along with the SQL performance viewer, you can kind of get two different views as to why something might be slow on your database, from what's blocking versus on the other side, what is being blocked or what is being slowed down because of that block.